7.7, operations on functions. That's the official title. Function composition will be the term you hear me say the most with this stuff. I'm going to kind of dive in with it, and I'll try to give you some more real life stuff in class. It's kind of a weird concept. The best thing to compare it to is substitution, what we did back with systems of equations. That's the most similar thing you have seen to this up to this point. Right now, before we do this first example, I do want you to write down two equations. Probably just want to pause it and write these down and come back. F of x equals x plus 2 and g of x equals 3x. You're going to use these two equations throughout the whole process here. Okay. So f of g of 2, that's how you pronounce this. So f of g of 2. The little o stands for of. Anywhere you see a parenthesis next to a function letter, that is also of. So probably first thing you want to do is rewrite this. Okay. This is also a same way to say f of g of 2. Nested parentheses. So f of g of 2. Okay. Well, I gave you g, so let's start there. We know g of x is 3x. Okay, I gave you that just a minute ago off to the side here. So the way you want to start this is to kind of, well, I guess kind of separate from the problem, just kind of maybe off to the side or down below, figure out what g of 2 should be. Okay, well, we know g of x is 3x. That's what I gave you. So that means you're plugging in 2 for x, so you do it like that. So g of 2 is 6. Okay, so that means up here, g of 2 is actually a 6. It gets replaced. And then we bring down the f, and now we're finding f of 6. Okay, well, we know f is x plus 2, so if f of x is x plus 2, well, that means I'm going to plug a 6 in for x, because that's what I'm finding here, which means that this is going to be 6 plus 2. Everywhere I had an x, I plug a 6 in its place, substitution. So f of 6 would be 8. That's our final answer. Okay, it's substitution basically done twice. So we start with the inside. We always start with the innermost parentheses. That's order of operations. Find g of 2. We figured out with 6. Once you get that, replace g of 2 with 6 and work out what f of 6 would be. Okay. All right. The next example will be the exact opposite of that. We'll find g of f of 2. Okay. It actually turns out to be a different answer. So we'll call this example 2. Probably again rewrite it, g of f of 2, and either off to the side or down below I would figure out what f of 2 is. So f of x we said was x plus 2, so let's plug in 2 for x and get 2 plus 2 or 4. Okay, so where I had f of 2, now I want to put a 4 in its place. It's substitution. Okay, well, g of 4, let's see what that turns out to be. Well, I know g of x, I gave you a minute ago, was 3x. So that means this is 3 times 4. Okay. I'm just taking 3x and I'm plugging a 4 in place of the x. It's replacing it. So that means that g of x, or g of 4, 12. And that would be our final answer. Okay. All right, so one sort of real-life example here. Shopping. Okay, using 2 coupons. So let's suppose that I want to buy some shoes here that are $149, but they're on sale for 75% of the original price. And to help me out even more, I've got another coupon that gets me 10% off anything I buy. Okay, so the question is, how much do I pay? And these are good things to be able to do in your head if you want to save you some money in the store. But the way I'm going to do this is probably different than the way you're probably thinking about an Algebra 1 level approach, which is just use your information, come up with some kind of way to figure it out and solve it. And that's fine, but I want to try to make this make sense as a function composition. So I'm going to define one function, f of x, that accounts for this 75% off. All right, so that means, or I'm sorry, 75% of the original price, not off. So that would be 0.75x. Okay, and I want a second equation that will account for my 10% off coupon. Now, be careful here because 10% off doesn't mean 0.1 times the price. It's 0.9 or 90%. You're paying 90% of the price. You got 10% off, but you're still paying 90% of the price. So that'd be 0.9x. I guess just in case you need to see this much detail, kind of off to the side here, remember that when you do a percentage to a decimal, if I'm 75%, I slide the decimal back 2 places. That's how I got 0.75. Or if I have 90%, I slide the decimal back. That's where I got 0.9 or 0.90. Okay, so that's just some preliminary stuff. All right, so basically I need to function composition here. With this one, it really doesn't matter. Either way, I'll get the same answer, whether I do f of x, or I'm sorry, f of g or g of f. So I'm just going to do f of g. And the x is the price. Well, it cost $149. So I'm going to put that in for g. Okay. So down to the, or probably off to the side, somewhere down below, let's figure out what g of 149 is. Well, g of x was 0.9x. So g of 149 will be 0.9 times 149. Okay. So go ahead and use a calculator, figure that one out. If we do 0.9 times 149, that's 134.1. Okay. Or let's, I guess, put it in money, so we'll do 0.10, $134.10. Okay, so that was g of 149. And we still need to find f of that. Okay, well, f is 75%, or 0.75 times x. So 0.75 times what I just found for x, 134.10. Okay, so let's figure that part out. And that'll be what I pay. So 0.75 times 134.1, it's rounded off, it's about $100.58. Okay, so pretty good deal there. That's how you would use function composition in real life. Now, I doubt you're going to go in a store and get that complicated, but it's kind of to give you an idea of something you've probably done in Algebra 1, but to now give you a higher level way to think about it. All right, these will get a little more difficult when we start getting away from numbers and just actually composing pure functions. So let's do one that we don't have a number to plug in for x. We just have an x to find. Well, earlier on I told you f of x is x plus 2. Okay, so for this one, there's no number to plug in, so there's really nothing to do down below. Again, think substitution. Well, I know what f of x is. I know it's x plus 2. That's what I gave you in the very beginning of the lesson. So now that means I need to find f of x plus 2. Okay? So maybe a better way to think about this is to rewrite f of x. F of x is x plus 2. And maybe go ahead and set up your parentheses to get ready to plug something in. Wherever you had an x, that's going to go away. Something else is going to substitute in its place. All right, so what's the thing that gets substituted? It's x plus 2. And again, I know that because I gave you f of x was x plus 2 in the very beginning of the lesson. So the way we finish this up is to say f of x plus 2 is x plus 4. I just combine the like terms I have, and that looks like a pretty big answer, but that's it. That's as far as I can take it. Okay. All right, let's try one more. And I'm going to introduce a new function h. So let me go ahead and define that one for you. H of x, you can add this to that list at the top of your page, the first two you did. H of x is x squared minus 2. Okay? Pause if you need to, write that down. Well, first of all, I'm going to start the innermost parentheses. I know what f of x is. It's x plus 2. I gave you that in the beginning of the lesson. So what we're really finding here is h of x plus 2. Okay? All right, so again, h of x is x squared minus 2. So I'm going to rewrite this again just to kind of help you see it. This is not necessarily how I would do it on my paper. But h of x was x squared minus 2. So something is going to get plugged in for x, which means something else is going to get plugged in for x over here. Everywhere I had an x, that disappeared, and we get ready to plug something in its place. All right, so the thing that gets plugged in for x was x plus 2, or f of x. Okay, so let's set that up. Okay, that's it. Well, not it, but at least the hard part. That's the substitution. Again, it works just like the substitution stuff you did back in chapter 6. So h of x plus 2, don't forget how to FOIL this. This is x squared plus 4x plus 4. Don't forget you gotta FOIL that out. And then minus 2, of course, at the end. So h of x plus 2 is x squared plus 4x plus 2. And that's it. Okay, so there you go. That's 7, 7.